Hi, this is Maggie. In this video we're going to talk about another data structure in Python that will allow you to store a collection of data called a dictionary. A dictionary allows you to store key-value pairs of data. Instead of the data being ordered and accessed by index, each data element has a unique key that is used to access or modify the data element. Keys in a dictionary can be of any immutable data type, such as string or integer. There are several ways that you can define a dictionary. We'll look at the most common, which is to use curly braces. We can list the initial key-value pairs in the braces, or we can use empty braces and then add key-value pairs. I'll demonstrate in the console. Suppose we want to define a dictionary to keep track of readers in a library reading program. Let's begin with a naive implementation that uses the readers' names for keys. So I can define a dictionary called readers as readers equals open curly brace, close curly brace. Now I can set the values of readers sub Edward as 100. I use the same sort of indexing that I use for list indexing, but instead of putting an index in the square brackets, I put the key. If there was already a key-value pair with Edward as the key in the dictionary, the value is now replaced with 100. If there isn't, as we know there wasn't because we just created the dictionary and it's empty, we have now added the key-value pair Edward 100. If I ask idle to evaluate readers sub Edward for me, it returns 100. If I ask idle to evaluate a key that doesn't exist, for example, readers sub Sarah, I get an error. We can use in to test that a key exists before trying to access it. So Sarah in readers evaluates to false, and I know not to try to access that value. Now it really makes more sense to key the readers by a unique value, and names aren't unique. If we have two readers with the name Edward, then they'll always be overwriting each other's hours. We need to use a unique value, such as their library card number or an email address. If we use a library card number, for example, then we'll want to store more information with each key. We can make the values lists with the name and the hours, and the key a library card number. I'll just make up a library card number and create a dictionary that way. We'll start over with an empty readers dictionary, and then I'll add readers sub 1, 2, 3, 4, 5 equals, and then the list Edward 100. When I ask idle to evaluate readers sub 1, 2, 3, 4, 5, it returns the list with Edward at index 0 and 100 at index 1. A dictionary is used to store event information in pygame. Based on the type of event, there will be different key-value pairs in the dictionary. This program is a simple event loop that prints the type of event and the event dictionary. The event type is an integer, so that's difficult to interpret without comparing to the pygame constants for event types. But in the dictionaries, you can see the keys are strings and the values vary in data type depending on the type of information. For example, with mouse motion events, we can see the position with key pos is stored as a tuple, and rel, the relative location to the mouse's last position, is also stored as a tuple. The key buttons allows access to a tuple with 3 values related to the state of the 3 mouse buttons. Clicking a button gives us an event with the position of the mouse and an integer indicating which button was pressed. And key press events give us information about the keys that are pressed. We won't go into a lot of detail on this here, but it's important to understand how a dictionary works so you can access information about an event. Dictionaries are a good data structure to choose if you have data that you want to access by a unique key. If we store the library reading program data in a dictionary, then we don't need to search for a particular reader. We simply type the key we're using, such as the library card number. They can also be used the way they're used in the pygame event object as a way to name elements in a small collection of data. Try writing a version of the library reading program or a similar program that allows you to add, remove, and find data stored in a dictionary structure. When you can write a program using a dictionary, you're ready to move on.